We're recording. Hello everybody, welcome to my video. I'm doing a chemistry lab experiment today. I have a high school chemistry student here. This is Josie.
Hello.
She happens to be my daughter. She's also a student, and I'm hopefully going to be a teacher, so I'll play the teacher and she'll play the student. So today we're going to be heating a mixture and observing how it behaves. Do you remember the definition of a mixture?
A mixture is two substances that have been mixed together but that are not chemically stuck.
Not chemically stuck. Okay. Yeah, they don't have a chemical relationship. Okay. So we've been learning about using graphs and collecting data. We're going to learn how to gather our data and save it on a graph, and then we're going to try to analyze what we observe by using our data. Let's talk about the experiment a little bit here. So we're going to, like I said, we're going to heat a mixture of water and isopropyl alcohol, and they both have different boiling points. Do you remember we looked those up?
Yeah.
Do you remember what the boiling points were? If you need to look at your notes, you can.
Yeah, I have my notes right here. The water boiled at about 100 degrees Celsius, and the isopropyl
alcohol.
Isopropyl alcohol boiled at about 82 degrees Celsius.
Okay, so what do you notice about those two numbers?
They're different.
They're different, right? That's important to know. Sometimes the obvious is important. Okay, so in general, when you heat a liquid, what happens to it?
It gets hot.
Right, okay, so it gets hot and it gets hotter as you keep adding heat to it, right?
It eventually boils.
It eventually boils, right, okay. So there's a time when you start heating it, between then and when it boils.
Mm-hmm.
And what is happening? You're adding heat to the liquid, and it's
getting warmer.
It's right. It's getting warmer. Okay. Let's think about the energy for a minute. Heat is a form of energy. So if you're heating a substance, you're adding energy to, say, our mixture. So what is happening to that energy? Do you know? Do you remember?
It's being used to heat the water.
It's heating the water. What? Where does it go? Does the energy go out the top? Does it become part of the mixture?
It's the backward. No, it doesn't.
It doesn't. Right.
I do not remember.
Okay. We talked about this earlier. The molecules absorb the energy,
Yeah.
and they start moving faster and faster. And the more energy they absorb,
the hotter it gets.
Right, which is a measure of how fast the molecules are moving.
Yeah.
Okay, so more heat is more energy, which is more movement of the molecules. Okay, so when we're running the experiment, I want you to think about the energy and the energy being absorbed by the molecules, okay? And when we're looking at the data, we'll be recording temperature, but temperature is another way of saying, more heat in the system. So think about the energy. One more question before we begin. So what do you think the graph will look like when we heat this mixture? It's going to go up.
Yeah.
It's going to go straight up?
No, not straight up. Okay.
How long will it go up?
Indefinitely.
Indefinitely? Couldn't go up.
I mean, until the end, until all the water is evaporated, right? It would just keep getting hotter and hotter the more you heated it. Wouldn't it?
So, at what point does the water boil?
100 degrees Celsius.
So when the water gets to 100 degrees Celsius, and you add more heat, does the water get hotter?
Maybe.
Does it go to 101 degrees?
Does it?
What do you think will happen? Will it go to 110 degrees?
I think it could get hotter,
Okay.
but I
Hotter
feel
than
like
boiling?
I
What's
am
hotter than boiling?
warmer than boiling.
Okay, well,
I feel like I'm wrong though.
we'll find out. Okay, we're going to do something here. We're going to switch webcams. This is kind of cool. We played with this. I'm going to pause the video and switch webcams. Okay, as you can see, we've switched webcams to show our hot plate, which is here, and it's very hot. And we're going to start our experiment. Josie is going to set up the. Do you remember how to change the time measurement? We want to measure it every 5 seconds.
Yes, I do. Should I do that now?
Yes, please.
Yeah, you go to experiment, data collection,
Good.
and then you change that. You wanted it at 5 seconds, right?
We do.
Every 5 seconds for
How long do we want to go? We want to do about 5 minutes.
330. Right?
That looks good.
0. Yeah, okay. So done.
Okay, so we're ready to start collecting data. And we'll do that as soon as we put the flask on the heat. So once you get up and ready to collect the data.
Did I press that green button? Oh, yes, I
Not
did.
yet. Okay, you can begin. So we should be collecting data. And you see that it's starting at 22 degrees.
Actually, it's starting at 24 degrees.
And tell me if you're seeing anything yet. I'm going to keep my eye on the flask.
It's changed a tiny bit. And it's changing a little bit more every time.
Okay, so we're putting heat into the system. And the heat is a form of energy, right?
Yeah,
And what's happening to the energy?
it is moving around inside the water faster. Molecules are being taken by the water.
Molecules are absorbing the energy.
Yeah. To put it in sciencey terms.
Sciencey terms. We like sciencey terms. Okay. Like you said, our graph, you thought our graph would go shoot straight up.
Not quite straight, but
Now, as you can see, the substance is starting to boil. So we should be at some boiling point. I think we might have boiled a little bit too soon. Now, do you remember what the boiling point of isopropyl alcohol was?
82, I think?
About 82. Now look at our graph. Where are we now?
At about 80.
At about 80.
Yeah.
80 and a half. That's pretty close to the boiling point of isopropyl. But what's happening to the graph?
It stopped changing so drastically,
Time is still going to the right, but it's not.
going up as much.
So remember we said when we were adding heat, the molecules would absorb that energy and it would be measured as an increase in temperature.
Yeah.
Are we measuring an increase in temperature here?
Yes. Not much.
No, but we're still adding heat, aren't we?
Yes.
So we're still adding energy. How is it that we're adding energy, but we're not seeing an increase in temperature? What's happening to that energy?
It's moving as fast as it can. It's all been absorbed.
Okay, but then we add more, we keep adding energy. At a certain temperature, we add more energy and we don't get more temperature. So the energy, what is it doing? Is it doing nothing? Is it doing something different?
It must be doing something.
How about the molecules? If they're not moving faster, what are they doing?
Moving the same. Moving up, higher.
Higher to where?
They're like evaporating.
Yeah, that's right. So when the substance boils, it's gotten to its boiling point, and the molecules start to evaporate. So maybe the energy has something to do with evaporation. What's our curve doing now?
It's still moving up.
Is it as flat as it was?
No, but it's not as steep as it was before. It was flat or even.
Okay, so it went up for a while, then it flattened, and then it's going back up again.
Mm-hmm.
So we still have some liquid, and we're still recording data, and our curve is doing what now? Seems to be
sort of evened out.
flattening out again.
Yeah.
At what temperature is it flattening out?
About 100. Well, about 98, but which
Close
is
to,
close to 100.
which
It's
is,
the boiling point for water.
okay, so we have two relatively flat spots here on the graph, which correspond to
The two substances that we are heating up.
their boiling points.
Yes.
Okay, so I'm going to take this off now. Why don't you stop collecting data? And we can look at our graph for a minute. Okay, we've done our experiment. We have our data here. We have this nice graph that goes up and over and up and over. I was hoping for a little more of a step on the second one, but we can see a little bit of a step here. I'm thinking that we heated it too quickly. I kind of know what happened here. I'm going to ask Josie to try and explain a few things. So earlier I asked you what you thought the curve would look like, what the graph would look like, and you gave me this. You said it would go up. But obviously when you heat things, the temperature goes up. Does this graph look like what you were expecting?
Well, this part looks a lot like what I was expecting, but
You thought the whole graph would look like that?
yes,
Up and up
I
and up?
did. I did not think that it would have like a little step thing there. The flat part.
Uh-huh.
But when it started going flat, I also wasn't expecting it to go up again. But now
So
I
you thought
understand.
flat, it was done.
Yeah, I did.
Oh, interesting.
I think because it didn't occur to me that there were two things in there.
But we talked about it being a mixture, and we talked about the two boiling points.
Yeah, and now I understand.
So the flat spots kind of correspond to the boiling point, don't they?
Yeah, almost exactly.
Okay.
That's where the alcohol boiled, and that's where the water boiled.
So when something boils, what is actually happening to the molecules?
They are evaporating.
They're evaporating. Okay. So the flat spots represent.
Or evaporation begins.
Right. So that's called a phase change when you go from a liquid to a gas. Or we could do another experiment where we measured a solid, like we could melt wax from solid to liquid. And we would probably have a similar graph with a rising temperature, then a flat spot where the phase changes from a solid to a liquid or a liquid to a gas. And since we had two substances in our mixture, we would expect to have two phase changes, one with the alcohol and one with the water. So that's what the flat spots are. Well, that's good. I'm glad that you were a little bit surprised by the graph and that we were able to figure out what it was. And maybe we can do more experiments in the future.
Yeah, sure.
All right.
That would be fun.
Well, thank you.
Thank you.
And
Bye, Dad's class.
bye, my class.